All right, so here's another trig substitution one. Now, that one looks almost like, oh, trig inverse function, right? What's the problem? Well, the ones I know the trig inverse of that have the plus is 1 plus x squared. It doesn't have a square root. You know, if it was a minus there between them, that's just a sine inverse. But the plus one, the only thing I don't have a square root of a plus in here. You see what I'm saying? So a little frustrating, but that's what it is. Okay. Yeah, this one is turns out it's going to be a trig substitution. Now, going back to the forms, trig subforms here. Which one is this? It's something plus x squared. Isn't that a tangent? So x equals a tan theta. What's the a? Well, that's a squared, so a would be 2. Then we'll do the 2 tan theta. With me there? Now also, well, the good news here is, you know, that's just only substitution for a. But I also need dx, so what's dx? Well, dx is the derivative of this, which would be 2 secant squared theta d theta. This is going to work out actually pretty nice. So make those substitution. X is 2 tan theta, so that'd be 4 plus 4 secant squared. Oh, 4 tangent squared thing. And then the dx is 2 secant squared theta d theta. Well, that part isn't too bad if you get the right choice there. Okay? Now, of course, what happens is this will simplify. What have I got here? But instead of having to write, let's do it this way. All right, so that factors off of 4, so that'll be 1 plus tangent squared theta. And 1 plus tangent squared, that's secant squared, isn't it? So this is 4 secant squared theta times 2 secant squared theta d theta up here. Hey, but that's nice. With me there? See where I got there? So that's 1 over just 2 secant theta, isn't it? Square root of 4 is 2. Square root of secant squared is secant theta. Aha! Still pretty nice because the 2's cancel. And we got secant squared, so we can go one of those down. So it's just the integral of secant theta d theta. All right. This one we can actually, I won't call it cheat, but we can actually go to the answer on this one, because if you'll take your formula sheet out there, you see the integral of secant, well, it's secant x dx on the sheet. Yeah, that one's on the formula sheet. So that's actually one that we'll use. It actually, to do it, it's a, what is it? It's an LN. I think you change it to, I think you might have to change it to cosine. But anyway, the good news is it's on there. Okay. Yeah. So we'll just use that. What is it? It's ln of absolute value of secant theta plus tangent theta. Is that what it says?
Yeah.
I can't remember exactly. Indefinite, so we'll put the plus c there. Okay. So yeah, unfortunately, on the trig substitution, there is one or more steps after that. After you get the integral, you still got a little work, because we need to change the thetas back to x's. Well, good news is on the tangent one, I got something for it, right here. X over 2 is tangent theta. So that that's going to change that over. To get the secant, I guess there's different ways, but usually we go back to our triangle here. Let's see, tangent is opposite over adjacent, TOA, it's the TOA of the socket TOA. So it's opposite, so if this is theta, so it's opposite over adjacent. Secant theta, well, secant theta is what's the reciprocal of the cosine, and cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Did you get that? So I do need the hypotenuse. I guess point, what is it going to be? Well, it's just going to be the square root of those two squared. Using our c squared equals a squared plus b squared. It's okay. So let's see, let's put them down. All right. So secant of theta, said it's hypotenuse over adjacent, so it'll be x squared plus 4 square root over 2. Plus tangent of theta is x over 2. Not what you meant. Plus this. Now we're good. It's okay? Oh, okay. Now, yeah, let's talk about this for just, because they'll do some tricky stuff for the answer. That's good. I mean, if you did that on the test, all right, you're good. But just FYI here too. All right, so we can combine these into one, can't we? Fraction. Because we already have a common denominator. Well, by properties of logarithms, can I write that as ln of the absolute value of x squared plus 4 plus x minus ln of absolute value of 2? And the reason I show you this is because this does cut it down, because isn't this just a constant? And so I can just kind of swallow it up with the constant here. Yeah, they'll probably, this answer, they would probably list it as this. Because this is just a constant, so just combine it with that constant. You might be saying, where did the divide by 2 go? And so that sort of thing they'll do. Okay. Like I said, if you get that one, you're good. But that is a little simpler. Okay. Try one more? Yeah. Sure, why not? While we're here. That one wasn't quite as long, but pretty long. Okay, how about the integral 1 over x squared times the square root of x squared plus 3 dx. All right, so again, it's not quite an inverse trig function, unfortunately antiderivative. Which trig substitution am I going to make here? The secant, sine, or tangent one? Again, I'm probably going to play off of this, right? The x squared plus 3. That looks like a x squared plus an a squared, right? It's not quite a nice a squared, but yeah, again, it's the tangent. Isn't that the tangent? So x equals a tan theta. And again, this one's not a nice a, but again, understand that's a squared in that trig sub form. So what's the a there? Well, it'll be the square root of 3, right? So x equals the square root of 3 times the tangent of theta. With me? Okay, so we've got the integral 1 over, and like I said, on these, all the x's get substituted for, so 3 tan theta goes in for all the x's. So this would be, so squaring that, what would that be? 3 tangent squared would be the square of that. And then the same thing for that, that's 3 tangent squared theta plus 3. Oh, and then my dx, forgot to do my dx, didn't I? Dx would be the square root of 3, root of tangent is secant squared, so it'd be secant squared theta, theta. And so that goes in for dx. Okay? Look good? Question? Concern? That is something?
When you put your 3 tan theta for the x squared, does your 3 not become a 9? Or does only the tan?
Well, it was the square root of 3.
Oh, that's
And
right.
so I'm squaring it. And so that's why I get 3.
That's right. Okay.
Yeah. Yeah, this one had the square root in it.
Yeah.
The x did, so
Okay.
when you square it, you just get 3. Everything else look okay? All right, well, again, this right here becomes, well, we can factor off 3, so it becomes 3 times the tangent squared theta plus 1. So that's going to become, let me get the other parts here written. That's going to become the square root of 3, and then tangent squared plus 1, that's secant squared theta. So if I square root all that, I'll have this right here. Just square root that, get the square root of 3, and that doesn't square root nicely, but it will cancel out nicely. But square root of 3 and then square root of that is just secant theta. Times the square root of 3, secant squared theta d theta. Oh, we did get some canceling. Square root of 3, square root of 3. Secant of theta, cancel with one of them. And we wind up, let's go ahead and write it, 1 over 3 tangent squared theta. Times secant theta, theta. Okay. So it didn't turn out as nicely as the previous one, where we could just go right to the antiderivative. We have to do a little work here. One, I guess we could go lots of ways, I guess, but to make it kind of simpler here, let's change this. Isn't this 1/3 and 1 over tangent squared? Isn't that cotangent squared? I don't know if that's entirely necessary to do, because that's still not a nice antiderivative form. Now, sometimes when you have these other trig functions besides sines and cosines, it's helpful to change to 2 sines and cosines, and this is such a one. If we change that 2 sines and cosines, here's what we get. Let's see, tangent is sine over cosine, so cotangent would be cosine over sine. So this is going to be cosine squared theta over sine squared theta. And then secant theta is 1 over cosine theta. And notice there, it does help a little bit. So it's 1/3 cosine theta over sine squared theta, and that's also going to work well because do you see how, don't forget about the one thing we started off integrating, or one technique that we started way back with. Don't forget about u substitution, okay? That comes in handy a lot. Can we do u substitution here? Yes, we can. We can do u substitution on that. You see it? U is sine theta. Du is cosine theta d theta. And so the way I do it is go ahead and solve that for d theta. So we have 1/3 cosine theta over u squared, and then du over cosine theta is my d theta. It's going to work, isn't it? It's just 1/3 times u to the minus 2 now. Du. That's just the power rule. We haven't seen that today, have we? Yeah, just the power rule. 1/3, add 1, so we got u to the minus 1, and 1 over negative 1, we have to do that. We got negative 1/3, and u, go back to this, it's sine of theta to the negative 1 power plus c. Now you have to be careful there. That is negative 1 power, it's not the inverse sign. So it does mean flip it over. Yeah. Make it. How we want it. Oop, no, we start with tangent. Okay. So it's, yeah, it is. That one is 1 over sine, which is cosecant. But still, I mean, we could. I guess we could just. Sorry. We could have just stopped there and said, let's figure out what sine of theta is, and then we can do the reciprocal. Either 6 of one, half dozen of the other, right? So how are we going to get the sine? Well, let's come back over here. We've got x over the square root of 3. That's my tangent. And so that's my opposite, and that's my adjacent right there. So that's theta. So the opposite's x, square root of 3. We'll need the hypotenuse, so the hypotenuse is going to be the square root of that squared plus that squared. Oops. Sorry. Square root of 3 squared, so it's 9. It's 3 plus x squared. And so sine, oh, we need cosine, I mean cosecant, but it's the reciprocal of sine. So. Hypotenuse over opposite, so that's secant, it's reciprocal of sine. So hypotenuse, so 1/3, negative 1/3 times cosecant hypotenuse, so it'd be square root of 3 plus x squared over opposite x plus c. Did I do that right? Believe that?